Guys, welcome back. This is episode 7 of my tutorial series on how to make a 2D game in Android Studio, and in this episode I'm going to be covering gyroscopic controls. But before I get into that, I have a few errors to fix. I got a comment pointing this out. It's that whenever you export your game to your phone and then press, say, the home button and leave the app running in the background and then re-enter the app, the screen will be completely black. And to fix that, we're going to go into our game panel class, and in our surface destroyed method, change this true to retry. And now we won't have a black screen, except we'll have another error now. And that is, when you get back on, the obstacles will have kept moving as if you never left it. And so you're pretty much bound to hit it as soon as you get back on, and we don't want that. So to fix that, go over to constants and add a public static long, and it's going to be init time. And now head back over to game panel, and in this surface created method, say constants.init time and set it to the current time. Alright, save that. Now head over to your obstacle manager, and in the update method, add an if statement that just says if the start time is less than the initialization time, basically, then say start time is equal to constants.init time. And that way it kind of restarts the start time whenever we get back on the app, so that it's not referencing a time from way long ago when half that time we may have spent off the app, you know what I mean? So that's that should fix that. And the last thing is we need to lock the orientation, and this is especially important for gyroscopic controls because we're going to be tilting the phone a ton, and it's bound to flip orientation if it's not locked. So go into your Android manifest file, and that's just under the app folder, then manifest, and then it should be the only file there. Then you're going to see this activity bracket, and it's going to be main activity, at least if you called it the same thing as me. And then right before this little closing bracket, hit enter to add a new line, and just do Android, and then say screen orientation, and it's going to be equal to portrait, and I believe that should lock it. Now go ahead and say, and now what we're going to do is get right into the gyroscopic controls. And it's kind of funny, we're not actually using the gyroscope. We're going to get our orientation from the accelerometer and the magnetometer. So what we're going to do is create a new Java class, and I'll just call it orientation data. And we're going to have this class implement sensor event listener. And what that allows us to do is essentially attach sensors to this class, and then whenever those sensors have a change in their values, this class will be listening for it and allow us to do stuff with those new values. And of course we get an error because we have to implement some methods, but before I do that, I'm going to do our instance variables. So we need a sensor manager, and we need our sensors, which we're going to be using the accelerometer, and go ahead and import that. And we're going to be using the magnetometer, and we are going to need to store the data outputted by those sensors, and that's done with float arrays. So we're going to need an Excel output and a mag output. And we're also going to need to store our orientation. So I'll do another float array for that, and I'll do a get method for it. And we also are going to want to store a starting orientation so that we can compare it to it and see kind of how much the players move. Not what it is reference to the world coordinates, but reference to how they started. So we're going to store another float array, and that's just going to be start orientation. And it's going to be equal to null for right now. You'll see why. And we're just going to have a public float array get start orientation. And now we need one more method whoops, and that's going to be public float array, or no, public void new game is what I'll call it. And basically, the start orientation, I want it to get tracked every time you start a new game, because say like you start a new game but you kind of start with your phone in a different position, we don't want it to act like you have it tilted. We want it to reset the reference point to what your phone is when you start the game, each game. So we need a new game, and that's just going to say start orientation. We're going to set it back to null. And that'll make sense in just a sec. And now I'm going to fix these errors by implementing the necessary methods. I'm just going to have it auto-populate them. And before we fill in stuff there, what I'm going to do is create a public void. Actually, first I'm going to create the constructor. So public orientation data. And now we're going to assign the manager. We're going to need to typecast it to sensor manager, and then we're going to do constants.currentContext.getSystemService, and then we need sensor service. Alright, and now our accelerometer is going to be equal to manager.getDefaultSensor, and then sensor.typeAccelerometer. And go ahead and copy this line because it's pretty much the same for the magnetometer. And sorry if I'm mispronouncing this, guys, but you should be able to understand what I'm trying to say. So this is going to be type magnetic field. And now that's good there. I'm going to make a public void register. And these are actually going to register the sensors to this class so that we're going to be listening for value changes in them. So we're going to do manager.register listener. And we're going to pass in this. I'll show you guys the arguments. If I delete this. Okay. I guess I need a colon. Whatever. So I'll just tell you guys. So it takes in a sensor event listener, which is going to be this class. Then it takes in a sensor, which will be accelerometer, and then it takes in a delay time. And so for that, we'll do sensor manager dot and then type delay to see your options. We're going to choose sensor delay game because that's the recommended delay for a game. But basically what this delay does is this method down here is called whenever a sensor's values changed. But that could be every fraction of a second. It could be being called constantly, and that could overload our phone, and we don't want that. So we got to set a delay in between how often this is called so we can avoid that. And that's what that is. And we can actually just copy this line and change the accelerometer to a magnetometer. And that should be good. I'm also going to create a public void pause, and that will unregister this listener. And that, so if we aren't needing to reference the orientation at all, then we aren't even going to bother with listening to the sensors because it's just unnecessary. It's just an inefficient use of resources, basically. Anyways, now we're ready to get into this method right here. What we're going to say is if the event.sensor, which is a sensor that just changed, and we're going to get its type, we're going to say if it's an accelerometer, then we're going to say accel output equals, and then we're going to say event.values. And then else if we have event.sensor get type is equal to the magnetometer, then we're going to say mag output equals event.values. Now we're going to say if both our data outputs are not null, so we have something in both of them, then we want to use it to calculate our orientation. And before we can do that, we need to get the rotation matrix. Now, a rotation matrix in general will take a vector from one coordinate system and rotate that vector to its corresponding position in another coordinate system. And in this specific case, the rotation vector will rotate any vector inside the phone's local coordinate system to the world coordinate system. And basically the local coordinate system is just a coordinate system centered on the phone, and the world one's basically centered at the center of the Earth, basically. So what we're going to do is we're going to create a float array called R for a rotation matrix. It's going to have 9 elements representing a 3 by 3 matrix. And then we need another matrix I, which is the inclination matrix, but that's not relevant for us, so I'm not going to go into details on that. And then we're going to do sensor manager dot get rotation matrix. So it needs some matrices to output to, which is going to be R and I, and it's going to take in our acceleration data and our magnetometer data. And if you'll, it's too late to see now, but this method actually returns a Boolean, and that Boolean tells us whether it was successful in getting the rotation matrix. So we'll say Boolean success equals that, and so we'll say if success, so it succeeded in getting the rotation matrix. Then what we're going to do is say sensor manager dot get orientation, and it takes a rotation matrix and a float array to output to, which is our orientation. And we're going to add another line now, and we're going to say if start orientation equals null, so it hasn't been set, then we ain't need to start our start orientation. So what we need to do is say start orientation equals a new float array with orientation dot length, same length as the orientation vector, and then we're going to do system. That does not seem to work. We're going to do system dot array copy, and our source array is orientation, source position 0, destination, start orientation 0, and orientation dot length. And so this basically copies the orientation array into the start orientation. And let me explain to you real quick why we can't just do this. Trust me, if you try it, it will not work. You have to create this array on its own and then copy to it. You can't just assign them to the same thing, because, and I may even do a Java series and get more in depth on this, but basically float arrays and arrays in general are not primitive types. They reference a object in the memory, and basically these variables just store a reference, not the actual object. And if we say start orientation equals orientation, all that does is set them to reference the same object in the memory. And so when we change orientation, and hence that object in the memory, start orientation will still be referencing that object, and so start orientation will change with orientation. It won't stay the same, and we don't want that. We want it to be assigned once and stay that. So sorry if that was a bad explanation, but I'll go more in depth if I do a Java series. But anyways, that should be done for this class. And now what we want to do is head over to our gameplay scene where we're actually going to implement it. And what we're going to want to do, of course, is create a private orientation data. I'll just call it orientation data, and a private long called frame time. And the reason why we need this frame time is I'm going to use the orientation. Basically, the further it's tilted, the faster I want the character to move in that direction. But that only gives us a speed. We need a change in time to multiply that by to get a change in position. So we're going to use frame time to track the time that elapsed between frames. So come down here into our update method and do it right before this player.update. You can't do it after, otherwise it won't work. And what we're going to do is say int elapsed time equals, and then get a typecast ready, and then we're going to say system dot, I don't know why it's doing that, just system dot current time millis minus frame time, and then we're going to say frame time equals system dot current time millis. And now one quick thing we got to do, just like we did in the obstacle manager, we got to say if frame time is less than constants dot init time, so we don't get that same problem as we would with the obstacles if we got off the game and back on. Okay, so now we have our elapsed time. And we also have a method for getting our orientation. And that orientation is a float array with 3 entries. And the entry with index 1 is the pitch, and entry with index 2 is the roll. And pitch will correspond to our player's movement in the y direction, and roll will correspond to our player's movement in the x direction. So we're going to go ahead and get those. We're going to have a float pitch, and that's going to be equal to orientation data dot get orientation. And actually, before we do all this, we're going to add a statement that's just going to be orientation data dot get orientation is not null, as well as orientation get start orientation is not null. So if they're both not null, then we can continue, but otherwise we're going to get errors if we try and do this. But our pitch is going to be get orientation at index 1 minus orientation data dot get the start orientation at index 1. So basically, this isn't really pitch, it's really delta pitch. It's a change, but nonetheless, we'll have that, and we'll have a float for roll, which is the same thing, just change these 1s to a 2. Alright, now what I'm going to do is, before I get into this, so the pitch value can go from pi to negative pi, but the roll value can go from pi over 2 to negative pi over 2. So if you tilt your phone all the way to the side for roll, it will only give half the value of if you tilted your phone all the way down for pitch. So I'm going to be multiplying the roll by 2 in just a sec to account for that. But what I'm going to do is say float x speed equals 2 times roll times, and then I'm going to do constants dot let's see here, dot screen width divided by, and I think around 250F will be good. We may end up actually no, I'm gonna do like 500. We may end up changing this. You really just have to play around with it. We'll see. And now I'm gonna do the y speed, which will be pitch times constants dot screen height divided by 500 as well. And I'm actually going to do 1,000. Basically what this is saying is when we have our phone tilted all the way down, then I want our player to go all the way across the screen in a second. That's how fast I want them to be moving. Because we do 1,000 because that's 1,000 milliseconds or a second. And now what we're going to do is say player point dot x plus equals, and then we're going to do x speed. Actually, I'm gonna do something a little weird here. It's again a ternary statement. I'm gonna say x speed, actually math dot the absolute value of x speed times elapsed time. So the number of pixels will be moving, and I'm gonna ask if it's greater than 5. And if it is greater than 5, then I want to add to the x coordinate the x speed times the elapsed time. But otherwise, I'll just add nothing to it because I'd say 5 pixels is a good margin for error, because they could be trying to hold the phone still, but hands are shaky and whatnot. And then for the y, we actually have to subtract, and that just has to do with what they consider a positive and negative angle. But we're just going to copy this and paste it, and I'm going to say y speed instead of x speed on both of these. Okay, go ahead and save that. And now I'm going to add one last line. We never added this earlier, but basically we don't want our player moving off screen. This wasn't possible earlier because we can't drag our finger off the screen, but now that we're just tilting, it's of course possible. So we're going to say if player point.x is less than 0, then we're going to set it to 0. And if it's greater than the screen width, then we're going to set it to the screen width. So we're essentially just bounding it right now. And we're going to copy this whole thing and do a very similar thing for the y coordinate. So go ahead and change these to y's everywhere that you see it. And instead of screen width, we're going to do screen height, obviously. Alright, and I believe that should cover it. And oh wait, actually, that's not quite it. I need you to go over to this game over portion. Where is it? Okay, on receive touch. And when we click to restart the game, what we're going to want to do is call orientation data.new game. Remember how we made that method so that it resets the reference point? We want to do it right here because this is when we start a new game. With that done, I believe we can start it. I'll overlay me playing it because it's kind of hard to test gyroscopic controls in a emulator, so I'll just give it a run on my phone. Alright guys, I ran it and I made a obvious mistake. That's a quick fix. I forgot to go over here into the gameplay scene and actually instantiate the orientation data. So just make it a new orientation data, register it, and we also need to set last frame to frame time to the current time. We also need to go over to our orientation data class and scroll up, and over here on orientation we need to set this to a new float array with 3 entries, and that should be good. Now we're going to go ahead and give this one a run. Alright guys, so I have it loaded onto my phone right now, and I'm going to go over and play it. It's a little hard to see, but as you can see, I can move my arm and the player goes there. I will admit it's a lot harder to play with gyroscope controls, but nonetheless it is working. If you feel like it's moving too fast, you can go and just modify that dividing factor in the X speed. And as you notice, if I turn my phone drastically and press start new game, it still starts referencing that orientation. So that'll wrap it up for this video. Thanks for watching and stay tuned for the next one.